Now, this is participation. We want to think about it. We're going to go through over some of the practice questions. We're going to try to get as much of it done as we possibly can in a 2-hour time period, right, or less. We also have a group that will be giving a presentation right at 10:15, I believe. I checked to be sure. Now, I would like you guys to stay and ask questions, or you don't have to stay and ask questions. I'll ask questions. I've been really good at that. So, but I'm sure that they would appreciate it since they're going to be doing it via home. And I can get pretty mean sometimes when I ask questions, so. Especially since people get cheeky. Okay. So, can you guys can all see the screen? Let's get that back. Okay, so the first question, it says, consider the hypothetical reaction. A plus 2B yields A, B 2. If 2 moles of A and 5 moles are placed in a container, how many moles of AB will be formed? And how many moles of which reactant will remain unreacted? Excited. Can you guys see it? Doesn't it need to be bigger? A little bit bigger. Is that better? Okay, so what do you guys think? What would be a good way of figuring it out? Now I'm gonna share something with you. We have 2 reactants, right? What are my 2 reactants? A and B, right? And so one of the reactants, since they also gave us, we have quantities for both A and B, right? And since we have quantity for both A and B, then, so since we have quantities for both A and B, we're gonna have to use both of them to figure out which one is extra, right? Okay, so we're gonna do 2 equations. One equation is starting with A. So if we have 2 moles of A, okay, that did not end up where I thought it was gonna. Let's try it. Not there. This is cool. Oops, that's a little too far. Sorry, I've got to use it. I've got a new gift and I'm working it out. So bear with me. Okay, so if we start off with 2 moles of A, now we know we're doing stoichiometry. We already know that we have coordinate balance equation. So what is the relationship between A and AB? Because we want to figure out how much AB we're making. Any guesses? Now, I said, if we know we have a chemical equation that's already balanced, this is our balanced chemical equation, right? You guys see that balanced chemical equation, right? We want to look at the relationship between A and AB. In our chemical equation, if I have 1 A, how many ABs can I make? I'm sorry. If I have 1 A, how many AB2 can I make? Let me be specific. That's right. If I have 1, I can only make 1 because look at the coefficients. What's in front of the AB? 1, right? I'm sorry, the AB 2. Okay. So my A, there's 1, and there's 1. So my ratio between. So for instance, let's break it down. If I had a cake, right? We're making a cake, right? We know a cake takes 3 eggs, right? If I'm making 1 cake, how many eggs do I need? 3, right? So that is just like my chemical equation here, right? So this is telling me if I have 1 A and 2 B's, I can make 1 A, B 2, right? That's what the equation tells us. It's telling us that we're able to sit there and make this, right? So then all you're doing is looking at ratios, right? You look at the ratio that's in your chemical equation, right? And it's just like what we do in the kitchen. So don't make it like it's something foreign. It's the same thing that you're doing. Only thing you're using your elements instead of using cakes, right? So they're telling us right here, we're starting off with 2A. So then we know that that's a 1-to-1 ratio. So for every 1 mole of A, I can get 1 mole of A, B2. Is that true? Right? So then I know that I can make 2 moles of A, B2. Now, if I start off with B, so I have 5 moles of B. Now, what is the mole ratio of B to AB2? The ratio meaning, what is the ratio based upon the chemical equation? But you're right, the answer is going to be 2.5 at the end. That's how much we're going to be able to make. But I need that ratio first. So for every 2 B's, how many ABs can I make? 1. So then I'm going to write that down. So for every 2 B's, because we're basing it upon the chemical equation. I get 1 AB2. And you're right, it's 2.5. Did all the hard work in your head. Okay, now the thing is that the one that's limiting, okay, if we have, let's do it like this. If I have 2 slices of bread or 3 slices of bread, right? And I'm looking to make cheese sandwiches. And every cheese sandwich requires 2 slices of bread, right? Okay, and 1 slice of cheese, okay? So the thing is that didn't quite work out. So I have 3 slices of bread, okay? And I have 2 slices of cheeses, right? How many cheese sandwiches can I make? I can make 1, right? Okay, because I only have, my limiting reagent would be my bread, right? My cheese, I have excess of, right? So you have to look at the one that you can make the lowest of, right? So by basing it on the one that we make the lowest of, that's going to give us our correct answer. So in this case, we know that we can only make at most 2 moles of AB. So then we can eliminate this guy, and this guy. Okay, now the second part of it. So if we have 2 moles of AB, right? Then how many moles of B are going to be needed to make that? And then how many moles are going to be left over? Right? So what we can do is, now we know we have 2 moles of AB, right? We can work our way backwards. So I'm going to put it in a different color so you guys. Okay, so if I have 2 moles of AB2, then how many moles of B will I need to make that? So then what is the ratio? The mole to mole ratio of AB2 to B. It's 2, right? It's 1 to 2, right? So for every 1 mole of AB2, I make 2 moles of B, or I need 2 moles of B. Okay, so then that's a total of 4 moles of B, right? Because 2 times 2 is 4. Okay, so in this case, in this situation, we know that A was limiting, B was in excess, because B, we only needed 4 moles of it, we have 5. So how much was unreacted? How much? 1, that's right. So we know 5 minus 4 is equal to 1 mole of B that's unreacted. Okay? So we know the correct answer is not the drawing. Okay? You say that works? Right? And so we're using what we know. That's the reason why we have a balanced chemical equation, right? Balanced chemical equation lets us to make those relationships, right? It's kind of like the same thing that we do in the kitchen. Okay? So you guys ready for the next one? Next one. Okay, so let's go ahead to the next one. While we scroll down and I clear up my board, did everybody get this down? Or do you guys need a minute? You guys on the other side, did you guys get it down? And you need to respond. You guys all get it down? Okay. No response? Thumbs up. Are you there? Okay, well, let's go ahead and clear this. Okay. Number 2, propane. C3H8 is burned as a fuel in heating homes. Write a balanced chemical equation for this reaction. What is the coefficient for CO2? First thing I want to do is to do what? I can just look at this. Right here. Okay, so we know, what are my reactants? What are my reactants? It's not carbon and hydrogen. Propane. I'm still working on it. And my other reactant was what? Was that my reactant or was that a product? What type of reaction is this? It's a combustion reaction. So we know a combustion reaction always requires what? It's not water. That's a product. Oxygen. And what's the chemical formula for oxygen? Okay, my products are CO2 and H8. Nope. Nope. What is the product of combustions? All combustion reactions have the same products. CO2 is one of them, and the other one is so thirsty. What was that? H2O. H2O, that is correct. It's water. Okay, is it balanced? No. Now, what do we need? We need to balance it. So how do I go about balancing it? It just magically does it itself. I enter in ChatGPT and it gives me the answer.
Write down the number of reactants.
I write down what I have, right? So I should probably write down what I have. So I have a C, I have an H, and I have an O. How many carbons do I have on my reactant side?
3.
How many hydrogens do I have? How many oxygens do I have?
2.
On my product side, what do I have? How many hydrogens? How many oxygens? Is that balanced? Okay, we know that's not balanced. So, what's next? What do I need to do? How can I balance it?
3 in the product.
Okay, so you're saying in front of the, what is that compound again?
Yes.
CO2? Okay, so I put a 3 here. Okay, so then that gives me, how many carbons? How many hydrogens? Oh, sorry. How many oxygens now? I have 6, and then somebody said 7, that's right. I have 7. So I have 6 here. So 3 times 2 is 6, and then I have 1 here. So that's a total of 7. Okay, so then 7 oxygens. Oops. Okay, is that balanced? No. Okay, what's next?
4 in front of H2O.
So 4 in front of the H2O. Okay, so 4 times 2, that gives me how many hydrogens? And then how many oxygens do I have now? So now I have 4.
10.
So I have a total of 10. 5 here? Okay. Okay, so now we have a balanced chemical equation. So what is the coefficient in front of CO2? So that is the correct answer. Okay, so our next equation. Our next question. Okay. So in the net ionic equation for the following, what are the spectator ions? Spectator ions. What are spectator ions? That's right, they're not going to change on either side of the equation. So the first thing that I have to do in this case is figure out what is able to dissolve. What do I mean by dissolve?
Then you have to balance it first.
Yes, that is the first thing. You're correct. We have to balance it. Is it balanced?
It is balanced.
It is balanced. Okay, so then we have this balanced chemical equation. So the next thing that we need to do is figure out what is able to dissolve, right? So what is able to dissolve? How do I know that things are able to dissolve? Is there anything that is given in our equation that helps us realize what is able to dissolve or what is soluble? If it's aqueous, right? So if we look at our equation, we have aqueous on our product side of the equation on both reactants, right? And then if we go to our product side, everything is aqueous, right? So normally, if we have a chemical equation, if we have a reaction happening, we get the formation of a precipitant, a gas, or a solid. Do you guys see the formation of a precipitant, gas, or solid? Does anything say S? Does it say G? Does it say precipitant gas or L? Sorry, a liquid, right? So does it say L? No? Okay, so then that should be a telltale sign. As soon as you see that both sides have aqueous, that's not going to react. There's nothing going to happen. So all of them are going to be spectators. So the correct answer should be all are going to be spectators. Does that make sense? So spectators basically means that they're not able to react. The way that you get reactions, right? The way that you get a reaction is if you have something that comes together that forms a solid, liquid, or gas, right? So that means that a reaction has occurred. Did you form a solid, liquid, or gas? If everything stays aqueous, there's something wrong, right? There's no reaction. No reaction, all of the things are spectators. Okay? So the correct answer is C. For cups of whiskey. This is challenging. Okay, so the question says 12.08 grams of A2 reacts with 96.08 grams of B2 to form 108.02 grams of A2B. What is the mole ratio of the molar mass of A2 to B2? Of A to the molar mass of B. So the law of conservation says what? Mass is the same, or what we put in, we have to get out, right?
Yeah.
Okay, so what we put in, we have to get out, right? So if we're putting in A to and B2 in our reaction, right? So then that should add up to a total mass of 108. And it isn't 108.09, right? Isn't that exactly what we get when we have the formation of, right? So in other words, in this case, we know that everything is being used, right? So everything is being utilized. So, but we also know that the ratio, right, from A to B for our compound, for every 2 A's, we have 1 B in our compound. Does that make sense? For every 2 A's, we have 1 B. You guys see that? Okay, so that's going to be important to us, right? For every 2 A's, we have 1 B. Okay, so that basically lets us know that for us to be able to use this entire thing, the molar mass has to be half that of A, right? So then for every A, so if we had A to B, get my calculator, or not a calculator, pencil. Okay, so for every 1A, we're going to need mass. So for every 1A, we're going to use half of B. Okay, so the mole to mole ratio has to be half, right? And then also like here, we know that for every 2 A's, we only use 1 B, right? Is that true? Okay, so if we go ahead and we do our ratio, our mass ratio, so we have that 12.09 divided by my B, which is 96. So what is that ratio? What is that going to be? From A.
0.12.
Okay. You said 2.1259? Or, so, how many times does 12 go into 96? 8, okay? So, in other words, we have a 1 to 8 ratio, right? We also, not only that, we also know that based upon this number here, we want to multiply that by 1/2. So my answer should be 1 to 16. So my correct answer should be B. So that ratio is going to be a 1 to 16 molar mass ratio. That one's a little bit tricky because it's playing with a combination of mass and then you're figuring out the molar mass. Okay, list the number of elements for each, list the number of atoms for each element in the formula unit for ammonium sulfate. So what is the first thing that I need to do? Do you guys smell cigarettes? Do you guys smell cigarettes?
No?
Smell. No. What is it? Because I'm over here. Okay, it's just me. Okay, so what is the chemical formula for ammonium sulfate? Was that the first thing I want to do? Figure out the chemical formula. Okay, NH4. And what is the typical charge on ammonium? Somebody said plus, that is correct. Okay, and then sulfate, SO4, with the -2 charge. So I can use my polyatomic table to find that, right? Okay, so then how many ammonium am I gonna need? I'm gonna need 2 of them. So I'm gonna need NH4, parentheses, 2, SO4. Okay, so how many nitrogens do I have? I have 2. How many hydrogens? 8. How many sulfur? 1. And how many oxygens? Okay, so my correct answer is you said B? D. D as in donkey. Okay, number 6. Okay, so right now we have, let's see, 1, 2, 3, 4, 5, 6. Okay, I want you guys to come over to this table here, but first go grab something to eat. So you guys are gonna be a team. And then I want you guys to come over to this table here. And you guys are gonna be a team. And then you guys on the board, you guys are gonna be a team. You guys have the possibility of earning, let's say, 5. The winner gets 5 points extra credit. The second place winner gets 3 points extra credit. And I'm just gonna be a nice guy today. The loser will get 1 point extra credit. Okay? So, Alicia and Layla, you guys are a team. Okay, so the way it works is, I'll keep score on the board. I'm gonna put the question up. You guys answer the question. Each team will get points for every question that they get right. Okay? And then, as I said, at the end of it, the team that has the most points gets number 1. The team that got the second most points gets number 2. Okay? And the team that's last gets last. Okay? So, you guys, Alicia and Layla, you guys are going to be texting to each other to work this out, try to figure out the points, and you guys need to put your answer up if you guys are going to get points. Okay. So I got the team 5. And then we got team 4. And then we got, I think there's 2 or 3 of them. Team 2. Okay, go grab food. Grab food first, and then we'll get ready. So the first question is on the board, number 6. Are you sure?
Are we off by something?
Yeah, because you're saying that this is moles, and that is moles. How many they both do moles?
Downstream.
Are you sure?
Yeah.
Both answers.
What's that?
Both
Okay, well, and talk to the rest of your table, because the rest of the table, you're answering for the whole thing. If you plug it in the calculator right, think about what you wrote down. I heard Dr. Henry. You got an answer?
Yeah.
Okay. I mean, maybe we're. You gotta go with your answer? You guys talk to each other? You guys all agree?
Yes.
Okay, you guys all agree? Okay. That is correct. So what was your answer? What you guys did? A. And. Okay, what did you say? What did you say? C is correct. C is correct. So let's talk about it real quick. We know that we have 0.88 moles. Okay. For every 1 mole, because we want to get rid of moles, we know that we have 6.022 times 10 to the 23rd. So that's why I didn't understand how you got 10 to the negative 23rd. You're just putting things up there because that's what you thought you saw, right? And then that would be atoms, or molecules, or tennis shoes. So, and that would give us 1.13 times 10 to the 23rd. Okay? Okay, so team 4, you guys got a point. Let's see. What did team 5 give me? I mean, I know what you guys gave me. So. Okay. You guys are correct. Team 2, good job. Good job. Keep it up. Keep it up. So team 2 and team 4 are doing well. I have to change your numbers now. Team 6, you got one more person, right? So you guys gotta make up some points now. Next question. Oh, this is good. Love these questions. It says a coolant is widely used in automobile engines. Coolant widely used in automobile engines is 38.7% carbon, 9.7% hydrogen, 51.6% oxygen. Calculate the empirical formula of the for the compound. Yeah, which one of these is this? Which one of these is this? I just thought I'd ask you. I know you guys are wrong, right?
So we're just gonna. Wait, wait, just one second. Yeah.
Okay, you got some answers?
Yeah.
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 Okay, so what do you guys think is the fourth one? Okay, so 5 is number 4, so. You guys say C. H. 3, O, and then you guys say same one? Okay, so let's see what the last group says. Are you guys ready on the other side? Do you guys see the problem? What do you guys got? Okay, got Team Melissa and Layla, what are you guys thinking? Okay, I'll give you guys got a minute. So you guys. Okay. You got D? Does all the online team agree? D? Okay, so let's go through it. We'll see what the answer is. Okay, so we know that we're gonna change this to mass. So we're gonna make the assumption that our coolant, we have 100 grams of our coolant, since we know that this is based upon mass. Okay, so then we're gonna make the assumption that we have 38.7 grams of carbon. We have 9.7 grams of hydrogen, and we have 51.6 grams of oxygen. The molar mass of carbon, 12. Just gonna say, what was that? 12.011. So we're just gonna say 12 to make it easier for ourselves. So then we have 1 mole of carbon. It's about 12 grams. Okay. So if we go ahead and do that math. Okay. 3.225. Moles of carbon. Then we have, this one is about 1 gram, right? 1.008 of hydrogen, 1 mole. That's just going to be 9.7. Then our last one is oxygen. Oxygen weighs, so let's just say 16. So, we're on a time crunch, right? Okay, I get 3.225 moles of oxygen. So I divide it by the smallest. So 3.225. And 3.225. So then we end up with 1 carbon, 3 hydrogens, and 1 oxygen. So then my formula should be CH3O. Okay, so everybody got a point for that. That's good. Okay, so the score is 1 to 2 to 2. Okay, you guys ready for the next one? Can I erase? Everybody got it down? There. Okay. So which of the following compound is the best example of a hydrocarbon? Okay, so let me give you the definition of a hydrocarbon. It has hydrogen and carbon only. So which one would be the best example of a hydrocarbon? Okay, you guys have an answer? You say you can't see?
I don't know my glasses.
A little bit. You can also look at the one that's probably closest to you. Gosh. I'm gonna stuff my face because I didn't have breakfast this morning. Yes. You have an answer? It's C2H5, and that's in parentheses, 2, and there's oxygen at the end of it. So, definition of a hydrocarbon is it has to have hydrogen and carbon.
Okay.
So what is the correct answer? So which one?
C.
Okay, so you guys say C, what do you guys say? You guys say C? The correct answer is C. Hydrocarbon only has hydrogen and carbon. So the correct answer is C, as in cat.
Obvious. So, chemistry.
Sometimes it's the most obvious answer.
Sometimes we just overthink it.
Yeah,
So it doesn't have like indoor element.
Nope.
Okay.
just a hydrocarbon. If it was organic, right? If it has carbon in it, it's considered to be organic, except for when you only have a single carbon. So like carbon dioxide wouldn't be organic, we consider that inorganic. But all the other ones would be organic. Okay. Okay, so yes, team number 2, the online team, they got that one wrong because they thought like you at first and said, well, that's too easy. Okay, you guys ready for the next one? Online? Are you guys ready? Okay, our next question says, what are the formulas of ammonium ion and the hydroxide ion in that order? You have an answer?
Yeah.
Come on, wait, let me come over because you don't want to get the other team the answer.
No, wait, okay.
What do you guys think? Okay. Online team, okay, online team says A. The correct answer is A. Good job.
Yeah,
You're right, you're right.
Okay, so the score is 3, 4, 3. It's a tight game. Okay, number 10. And the complete combustion of C3H8O3, how many moles of carbon dioxide are produced when 23.0 grams of C3H3O3 burns? Okay, you guys have answers? Everybody put up their answers.
Second one first.
What do you guys think? Okay. Online, what do you guys think? Okay, so we got A, B, B. Okay, so let's see who was correct. First thing that we need to do for this problem is to do what? Nope. Say that one. Balance the equation. So we need to write the chemical equation. So first off, we need to figure out what the chemical equation is. So what is the chemical equation? So we know my reactants are CH C3H8O3 plus, it's a combustion reaction. So then what is the other thing that is always required for combustion reactions? Well, that's what we make, but we need something else. That's also what we make. We need oxygen. So anytime you need fire, so in life, real life, right? If there's a fire, if you remove all of the oxygen, right, then the fire stops. You need oxygen for a fire to keep going, right? So if there's a kitchen fire, cover it, right? Cover it, don't let any oxygen in, and it'll burn itself out because it'll use up all the oxygen. And we're gonna make, what did you say? You said it just a second ago. Carbon dioxide and H2O. So always when we have combustion reactions of organic compounds, we're gonna make carbon dioxide and H2O. Okay, is it balanced? So on my reactant side, how many carbons do I have? 8 hydrogens and 5 oxygens. Sorry, I had a brain fart for there for a minute. Okay, on the reactant side, how many carbons? Hydrogen,
2,
oxygen,
3.
Okay, is it balanced? No, what do I need to do to balance it?
You're gonna put 5 next, before,
On the
or
right
2
hand
on the
side.
right side.
Before the what?
Oxygen.
Before the oxygen?
Yeah, like that. And then you're gonna put 3,
And carbon.
that's like that. And then 4.
Okay, so then that means we have 8, we have 3, and we have 10.
Yeah.
Okay, are you sure?
Oh, extra. Okay, so then that would be. Three will be- So there's. And one. So it would be good.
So if I'm correct, we should have 7 halves here, right? And then that will give us our total of 10.
Yeah.
Well, we know that we can't have a half,
Yeah.
so we're gonna multiply everything by 2.
Yeah.
So we multiply everything by 2, I'm gonna put that in purple. So 2 times 1 is gonna be 2. 2 times 7 halves is gonna be 2 times 7 halves is gonna be 7, that's right. 2 times 3,
6.
and yes, and 4 times 2,
8.
8. Okay, so then that's 6, that's 16, and then that's 20. And then over here, we have 6, 16, 20. Okay, so we're good on both sides. Okay, so now that I'm good on both sides, I have a balanced chemical equation. What is my given? 23.0.
Wow.
And that's a C3, H8, O3. Okay, now what am I gonna do? Because I know that this is here is quantity, right? So that means moles or atoms or molecules, quantity. This is a mass. So what do I need to do?
You're gonna put like the 3, the 6.02.
No. How can I change mass into quantity? I'm gonna use the molar mass. So what is the molar mass of C3? C3, which has 3 carbons. So carbon is 12, 12 times 3. Hydrogen, how many hydrogens do we have? 8 times 1. Oops, okay, 1 times 8. And then oxygen, how many oxygens do we have? 3. And oxygen is about 16. Okay, so that's what, 36, 8, and 48. And we're gonna add those together. Okay, so approximately 92 grams per mole. Okay, so then, okay, so we have 92 grams over 1 mole of C3H8O3. And so what is the mole to mole ratio of C3H8O3 to carbon dioxide? The mole to mole ratio. The moles of C3H3, let's say C3H8O3 to the moles of carbon dioxide. What was that?
Can you repeat that question?
The question is, what is the mole to mole ratio of C3H8O3 to carbon dioxide? It's 2 to 6. So we know that we're going to put this in the bottom because we're trying to get rid of C3H3. So for every, based upon our chemical equation, we're going to have 2 moles of C3H8O3 to 6 moles, which is going to be on top, of carbon dioxide, because that's what we want. So what we want always goes on top. Okay? Okay, so if you guys had put the answer, the correct answer is B as in boy. Team 4 is taking the lead all by the well, they're ahead to lead by themselves. So they maintain the lead. Team 2 online, you guys are in second. Team 3, you're bringing up the rear. Gotta use those brain powers. Let's go, teams. You guys ready for the next one? Did everybody get that down? Yes? Okay. I'm clearing it now. So which of the following defines the percent yield for a reaction? Percent yield for a reaction. everybody put up your answers, you guys have your answers? Online, do you guys got your answers? Okay, six. Is your pride getting away? A little bit. A little bit, and you gotta let it go, that's what we learn. You're gonna make mistakes. Think about it. Percent yield, percent yield. For day, okay? Gonna go with A? Okay. Okay, everybody has an answer? So everybody said A. The correct answer is A. Percent yield is your actual over your ideal. Ideal is what we calculate, right? Actual is what we actually got. And then we multiply it by 100. It has to be percentage, right? Percent yield. Good job, guys. Okay, you guys ready for the next one? Are you getting your little cheat sheet made right now?
Yeah.
That's pretty smart. Hey, you guys ready for the next one? Okay, now you know the definition of percent yield. It says, in a general chemistry laboratory experiment, a student produces 2.73 grams of a compound. She calculates the theoretical yield as 3.4 grams. What is the percent yield? You guys have an answer? Everybody has an answer. And online, do you guys have an answer? Okay, she already has an answer. Okay, everybody said it was B. B is the correct answer, right? So we know percent yield is actual over ideal. So we have 2.73 as our actual divided by our ideal, which is 3.40. And we multiply that by 100%. Okay? And it's still a pretty close race, you know? Don't worry, I will. Okay, the next question says, calculate the mass of sodium oxide that can be produced by the reaction of 4.00 grams of sodium and 2.00 grams of oxygen. In the reaction, 4 sodium plus 1 oxygen gas yields 2 sodium oxide. I strongly recommend that you guys look back at one of the problems that we've done before. It'll help. Although it had letters, it didn't really have, it had letters and moles instead of. Okay, are we ready? See, I just need some more room for some more food, you know? Yes. Yes, okay. Remember, mass. So that's mass, right? That's moles. Remember, you need your gateway. Okay, I give you guys 3 more minutes. 3 more minutes. I don't need an answer.
Have you ever gone like an IQ test?
What's that?
Have you ever gone like an IQ test?
Yes, a long time ago.
What was yours?
I can't remember. It was pretty good, but I can't remember.
Was it
exact
over
numbers.
like 80?
Yeah, it was over.
Really? This is considered like really dumb, like how dumb.
Okay, do we have it? You guys ready for an answer?
Yeah.
Okay, so I know you guys already gave me yours. And then you guys. You're sweating? Okay, thank you. You have 5 possibilities, 5 choices. You guys think it is?
Okay, I will take it.
Okay, so everybody said D, as in donkey. Okay, so let's work it out. Let's see what it is. Okay, so we know that this is a limiting reagent reaction. So basically, you have 2 reactants. They gave you values for 2 reactants. They don't just say, yeah, it's 1, and you can't figure out everything else. So we need to figure out which one is the limiting one. Okay, so we're going to go ahead and we're trying to make sodium oxide. Okay, so then we're going to start off with the 4.0 grams of sodium. And then down here, we're going to start off with 2.0 grams of oxygen. So what is the mass of sodium? Mass of sodium?
We just rounded.
It's what?
We just rounded it 23.
Good. 23. 23 grams Na. I thought you said 28. I'm like, that doesn't sound right. It's going to be 1 mole of sodium. And we know for every 4 moles of sodium, we have how many moles of sodium oxide? We have 2. That's right. And we know that sodium oxide weighs, so we know sodium, we have 2 sodiums. Sodium weighs 23 times 2. And then we know that oxygen, we have 1. Oxygen weighs 16. So we add those 2 together. We get 32, sorry, 42.
26 or 46?
What was that?
Is it 26 or 46?
Oh, sorry, 46, thank you. See, I'm glad somebody's paying attention. So I'm just gonna write up anything right now. So then that's 62. 62 grams per mole. So for every 1 mole of sodium oxide, we have 62 grams of sodium oxide. Okay, so if we do that math, 4 is going to cancel out. So we have 2 times 62 divided by 23. It's 5.39 grams. Okay, down here, if we use our oxygen, so we have 2 grams of oxygen for every, we know that oxygen weighs 16 grams for 1 mole of oxygen. We know that for every 1 mole hold on. 2 grams of O2, my bad. So then that's 2 oxygen, so then that's 32 grams, my bad. I almost did the same thing that I always tell you guys not to do. Remember that it's diatomic. There we go. Okay, so 2 divided by 32, and then we know for every 1 mole of O2, we end up with 2 moles of sodium oxide. And we know that sodium oxide weighs 62 grams. And then that's 1 mole. So if we do the math, Okay, so we know we go with the one that's the lowest. So which one has the lowest value? What was that?
509.
Okay. Okay. So the correct answer is D. Yes, did a good job. Okay, this one is for the last question, number 14. 14. Number 14. Okay. Fix that. So this down here, so you guys know, I'll have to, it looks like I lost symbols. My symbols got screwed up. This guy should be delta H. Delta H. So this one is worth 4 points. 4 points. You guys did this in the very, very beginning. It was like the second thing that we did. It was like our second lectures. It's part of chapter 2. What was that?
Hello, Professor.
Hello?
Yes, I had a question. I have a presentation today with my group at 10:15.
Yeah. We'll be going over to your group in a few minutes, if you don't mind. Waiting a few minutes.
Okay.
We're on our last question, so. And
Okay, thank you.
give a presentation as well too, so. Is your whole group here?
Yes.
Yes, we're all here.
Okay. Do you guys have answers? Answers? Yeah.
Yeah.
Okay. Which student? Which one? Okay, what should you guys think? Okay, so we're gonna get you guys ready while okay. Alicia, that's your answer for this last one? For 4 points? Which one? Okay. Wait, what did you say? Okay. 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 What do you guys think? Yeah, 5 possibilities. You're gonna go with the last one? The correct one is the last one, and everybody said correct. Okay, so this team, you guys get 5 points. The online team gets 3 points. You guys get 1 point. Good job, guys. So I'll be adding those to your test. I'll either add it to your test or to your, I'll see which one gives you the best points. Your test or your final. Listen, so I'll take it back. I don't have to give you anything. Oh, yeah. Okay, so go ahead and grab some food. We're gonna get the team. They're gonna give a presentation. So, okay, you guys ready?
Yes.
Okay. So let me get set up. Let me stop sharing, and then you guys can start sharing.